The cosmos has always been a source of wonder, its vastness stretching far beyond the limits of our comprehension. For centuries, humanity has gazed at the stars with awe and curiosity, trying to decipher the secrets hidden in the dark tapestry of the night sky. The universe, immeasurable, ancient, and seemingly infinite, has kept many of its truths veiled from us. Despite centuries of scientific inquiry and technological innovation, countless enigmas remain unresolved, standing like silent sentinels between us and a deeper understanding of the nature of reality. Among these cosmic mysteries, some defy all explanation, challenging the very foundations of physics and astronomy. In our quest to explore the farthest reaches of space, the limits of our tools and perceptions often hold us back. And yet, progress continues. New instruments more powerful than ever before have granted us unprecedented access to the outermost regions of the universe. But even with these advancements, the cosmos continues to surprise us. In recent years, a series of remarkable observations have shaken the scientific community to its core. Using one of the most sophisticated tools ever built for astronomical observation, the James Webb Space Telescope, astronomers have recorded data that call into question many long-held assumptions about the origin and fate of the universe itself. Launched in December 2021 and fully operational since mid-2022, the James Webb Space Telescope, JWST, represents the pinnacle of space-based observational technology. With a $10 billion price tag and decades of planning behind it, Webb is designed to peer deeper into the universe than any previous instrument. It far surpasses the capabilities of the Hubble Space Telescope by using infrared imaging to detect extremely faint light sources from across the cosmos. This allows it to explore epochs of the universe that were previously beyond our reach, epochs that date back to just a few 100 million years after the Big Bang. One of Webb's major missions is to study light from the earliest stars and galaxies whose emissions have been stretched into the infrared spectrum by the universe's ongoing expansion, a phenomenon known as redshift. In July 2022, the telescope began scanning long-wavelength radiation emanating from the most distant galaxies. This redshifted ultraviolet light carries with it clues about how the earliest cosmic structures formed and evolved. To the surprise of many scientists, the telescope revealed structures and patterns in the deep universe that should not exist according to our current cosmological models. But perhaps the most astonishing and disturbing discovery came with the detection of something missing: the sudden and unexplained disappearance of an estimated 900 trillion stars. The disappearance of such a staggering number of stars without any accompanying evidence or known cause has provoked intense debate among astrophysicists and cosmologists. The question is both simple and terrifying. Where did they go? Stars don't simply vanish. Their life cycles, from formation to supernova or collapse into black holes, are well documented. Yet Webb has observed vast regions of space where entire star populations appear to have faded into nothingness. This phenomenon doesn't align with any existing model of stellar evolution or galactic dynamics. Two primary theories have emerged to explain this phenomenon. The first is conservative, suggesting that the stars may still be present, but their final stages were dim and obscured. It's possible they burned out gradually, emitting such low levels of light that they now fall below the detection threshold of even the most advanced instruments. Cosmic dust and interstellar material could also be veiling them from view, or they may have collapsed directly into black holes without producing the usual bright supernova explosion. The second theory, however, is far more unsettling. It posits that the universe itself may be undergoing a fundamental transformation, perhaps even a slow process of unraveling or decay. This would imply that entire structures within the universe are disappearing as a result of a deep, underlying mechanism that we do not yet understand, and that we are powerless to stop. To place this in context, we must revisit a key concept. In modern cosmology, the expansion of the universe. Since Edwin Hubble's groundbreaking observations in the 1920s, scientists have understood that the universe is expanding. Galaxies appear to be receding from one another, not because they are flying through space, but because space itself is stretching. This expansion was originally assumed to be slowing due to gravity, but a shocking discovery in the late 1990s revealed that the expansion is actually accelerating, driven by a mysterious force now known as dark energy. dark energy, which makes up about 68% of the known universe, counteracts gravity and drives galaxies away from each other at an increasing rate. This has profound consequences. As the universe expands faster and faster, it becomes increasingly difficult, eventually impossible for light from distant galaxies to reach us. Even if we could travel at the speed of light, most galaxies would remain forever beyond our grasp. When we observe a star whose light took 100 years to reach us, we see it as it was a century ago, 100 light-years away. But with galaxies billions of light-years distant, the expansion of space means they are actually much farther now than when their light was emitted. On such cosmic scales, the effect of expansion becomes dominant. Light stretches as it travels, shifting toward the red end of the spectrum. This redshift is a key observational signature of expansion. If space weren't expanding, the light's wavelength would remain constant. The James Webb Space Telescope has detected extreme redshifts in some of the farthest galaxies ever observed, strongly confirming this cosmic acceleration. But beyond simply confirming expansion, these measurements allow scientists to reconstruct the history of the universe and probe its composition. By comparing the apparent brightness and size of galaxies at various distances and measuring their redshifts, astronomers can determine how the universe has changed over billions of years. According to current models, the composition of the universe is as follows: 68% dark energy, 27% dark matter, 4.9% ordinary matter, like protons and neutrons, 0.1% neutrinos and antineutrinos, and 0.08% photons. No measurable evidence exists for exotic structures like cosmic strings or other hypothetical phenomena. With this data, scientists apply Einstein's theory of general relativity to simulate the past and predict the future of the cosmos. The results are sobering. Dark energy ensures that galaxies not gravitationally tied to the Milky Way will continue to recede. The space between us and these galaxies grows larger at an ever-increasing rate. Eventually, they will vanish from our sky, not because they cease to exist, but because their light will no longer be able to overcome the rapid expansion of space. This leads to a harrowing reality. Many galaxies are already unreachable. Our observable universe spans about 46 billion light-years in every direction, yet due to accelerating expansion, only about 6% of the total estimated 2 trillion galaxies remain accessible to us. Every passing second renders another 20,000 dalacids to 60,000 stars unreachable. Though we might eventually see the light they emitted in the past, the photons they release today will never reach us. This cosmic isolation paints a haunting picture of the universe's fate. Unless we find a way to escape our local group of galaxies, which includes the Milky Way, Andromeda, and around 60 smaller satellite galaxies, we will be stranded in a dark, increasingly empty region of space. Communication with the wider universe will fade. Interstellar messages will never arrive. And entire galaxies will disappear into the void, unreachable forever. Although this truth is unsettling, it also imbues the present moment with profound significance. We are living during a uniquely privileged era, a time when the universe is still visible to us in its full glory, a time when we can look up at the stars and see ancient light from distant corners of the cosmos. But that window is closing. If we wish to one day explore the universe beyond our galactic neighborhood, the time to act is now. The future of space exploration depends on our ability to innovate, to think boldly, and to advance rapidly. The cosmic clock is ticking, and with each second, more of the universe slips beyond our reach. Of the estimated 2 trillion galaxies that exist, 94% have already become inaccessible due to the accelerating expansion driven by dark energy. Unless humanity develops breakthrough propulsion or wormhole-based travel methods, we will remain permanently confined to this dwindling island of light surrounded by an ever-growing darkness. The expansion of the universe is not something we can stop. It is a fundamental feature of the cosmos embedded in the very fabric of space-time. As such, we must confront this reality with both awe and urgency, awareness that we live in a universe of fleeting opportunities and hidden wonders. If you found this exploration of cosmic mysteries compelling, we invite you to support our efforts. By liking this video and subscribing, your engagement helps us continue to share the most fascinating insights from the frontiers of space science and cosmology.